Good morning, friends. Today we are going to discuss some part about relative motion and dependent motion. Now, relative motion is basically, apparent motion, the motion that you feel. The difference between absolute motion and relative motion is mentioned here. The motion of a particle with respect to fixed frame is called absolute motion, but the motion of a particle relative to a set of axes which are moving is called a relative motion. In simple words, relative motion is the feeling of the motion basically. It's not an absolute motion. The great example is of two parallel trains. Suppose you are sitting in one train moving in one direction and second train moving in opposite direction. When you say for example, when you sit in the train and if that train is moving at a speed of say 40 kilometers per hour, and the train which went in opposite direction is moving with say 20 kilometers per hour, but you feel as if that train went with 60 kilometers per hour speed. Now that is the relative speed of that train with respect to your train. Consider exactly opposite. If two parallel trains are moving along the two parallel tracks, forget about any other entity. You are sitting in one train. If both the trains are moving in the same direction with same speed, and if you avoid or if you do not consider the sound created by the trains, you feel as if the both the trains are stationary. So this is nothing but the feeling that you get because of the motion of both the particles. When both the particles, both the bodies are moving, you can't have the realization of absolute motion of the other particle because you are also moving. So in simple words, if particle B and particle A is moving, both are moving, then this position in vector form RB dash A, that is RB minus RA, is the relative distance between A and B. Similarly, if you differentiate with respect to time distance, you get velocity. So this is relative velocity of B with respect to A, and this is relative acceleration of B with respect to A. You can determine position of A if the axis is fixed. Say A is having coordinates 2 and 3. But what if both the particles are moving and your reference axis is also moving? Then that position will always be changing. And that's how you determine the relative velocity. Just simple words. VB minus Va means relative velocity of B with respect to A. So imagine you are in a plane B and some person is in plane A. Your absolute speed or velocity will be different, and the speed felt by the person sitting in A can be determined by the subtraction of both the absolute velocities. Now we will understand it better when we see the numericals. So just remember this relative velocity means what. Now take example. A train moving at 45 kmph is hit by a stone thrown at right angles with a velocity of 22.5 kilometers per hour. So convert those velocities. Now remember, in relative velocity you can express the velocity as v bar is equal to vxi plus vyj. Remember, vxi plus vyj. So convert karo isko. Then this is acting along horizontal direction, this is acting along vertical direction. So accordingly उनको IJ के फॉर्मेट में हम कर सकते हैं एस्टेब्लिश. V of train 12.5 मीटर पर सेकंड एंड Vs that is stone वो -6.25 क्योंकि डाउनवर्ड डायरेक्शन में है. एंड रिलेटिव वेलोसिटी ऑफ स्टोन विद रिस्पेक्ट टू 10, सिंपल इनका सब्ट्रैक्शन करो, वेक्टर सब्ट्रैक्शन, एंड यू विल गेट दिस इक्वेशन. अंडर रूट करके उसका जैसे हम रिजल्टेंट करते थे वैसे निकालो. सो 13.97 मीटर पर सेकंड. नाउ रिमेंबर, the absolute velocity of the stone, the actual velocity of stone is 22.5 kilometers per hour, that is 12.5 meters per second. But the person sitting in the train would feel as if that stone is coming in his direction at a speed of 13.97 meter per second because he is also moving. That's how relative velocity works. Now the throne is the stone is it is mentioned that stone is moving in uh, the stone is moving perpendicular to the train, but apparent angle will be 26.56 degrees for the person who is observing from the train, and this is how the relative angle is determined. Similarly, look at this example. Three ships, the velocities are given, and we are asked to determine the velocity of ship A, velocity of ship B observed by A, that is VB minus VA, relative velocity of B with respect to A, velocity of C observed by B, that is relative velocity of C observed by B. So in this example, we have the velocity of C 1.5 meter per second, velocity of B as 0.8 meter per second. We are asked to determine velocity of A. So velocity of ship A is can be easily determined with this equation. Express this VB and VC in IJK format. It is very simple. So resolve it as we used to resolve force. 0.8 cos 45, 0.8 sin 45. Similarly, C, and relative velocity of AC is given 4 meter per second at 60 degrees angle. So this is also given. You are not going to have any numericals on this, but you need to understand the procedure. So V bar AC is equal to, we got this equation, and after simplifying you get velocity of acceleration, sorry, velocity of ship A as 4.506 meter per second. And it means what? This is the absolute velocity, this is the apparent velocity, relative velocity. Actual velocity है 4.506. The person who is sitting in ship C would feel as if velocity of A is 4 meter per second, but actual velocity of A is 4.506 meter per second. Similarly, velocity of B observed by A is determined. See, ship A is actually moving with velocity of 4.506, but person sitting in B would feel as if it is moving in that direction with a velocity of 5.01. So this is the apparent velocity, and that's how all the numericals are solved. Just go through these numericals. I hope it will be helpful for you, but do need one thing: read these numericals carefully. You're not going to have any numerical on this. You don't need to solve the numericals. Just go through the procedure, and so that in remaining syllabus while solving the numericals you will be familiar with the concept. Thank you.